The asteroid belt is located between the inner and outer planets, that is, between Mars and Jupiter, at an average distance of 1.9 to 4.2 astronomical units from the Sun. So far, tens of thousands of asteroids have been identified, but according to estimates, there may be as many as several million. Approximately 200 of these asteroids have a diameter of over 100 kilometers. The two largest objects in the asteroid belt are Ceres and Vesta. Ceres is the largest object in the asteroid belt, but the smallest of the dwarf planets in the solar system. After Ceres, Vesta is the second most massive body in the asteroid belt. Its shape is close to an oblate spheroid, but because of the protrusion at its southern pole, it cannot be classified as a dwarf planet. The diameter of Ceres is 1/12 of that of the Earth. Ceres alone makes up more than 1/3 of the mass of the asteroid belt. However, its mass is only 1% of that of the Moon. The diameter of Vesta is barely 4% of that of the Earth. Its mass is 0.4% of that of the Moon and 1/10 of that of the asteroid belt. Ceres has a thin, dusty outer crust. Its mantle is rich in frozen water. It contains more water than the Earth's freshwater resources. Ceres has a solid, rocky inner core. The mission of the Dawn space probe is to study Vesta and Ceres, the two largest objects in the asteroid belt located between Mars and Jupiter. Both formed in an early period of the solar system, but their further growth was prevented by Jupiter's enormous gravitational pull. By studying Ceres and Vesta, we can learn more about the early period of the solar system and the formation of the rocky planets. Dawn carries 3 instrument systems: a framing camera to take photos, a mapping spectrometer to map surface minerals, and a gamma-ray and neutron detector to analyze the chemical composition of the two asteroids. Dawn is the first space probe to orbit a dwarf planet, and the first to orbit 2 bodies in the solar system. It was launched on the 27th of September 2007 and flew by Mars to complete its gravity assist maneuver in February of 2009. Dawn entered into orbit around Vesta in July of 2012 and studied it for 14 months. It reached Ceres in March of 2015. The Dawn space probe is propelled by ion thrusters. These are 10 times more efficient than chemical thrusters. When placed in an electric field, the particles of the ionized or electrically charged gas are accelerated. If the accelerating voltage is high enough, the kinetic energy of the ions will be higher than that of the burning gases. The greater efficiency enables the space probe to reach 2 destinations in the solar system beyond the Earth-Moon system. The ion thruster utilizes xenon gas. The gas is injected into the ion thruster, where the xenon atoms are ionized by bombardment with electrons. The positively charged xenon ions accelerate in the electrostatic field and are ejected at high speed, while they are neutralized by electrons. According to the law of action-reaction, the space probe is accelerated in the opposite direction from that of the ejected ion cloud.